Hello, in today's class we're going to be doing an introduction to vectors.
Let's now talk about vectors. First, before we get into vectors, let's talk about what scalar quantities are. Scalar quantities have magnitude but no direction. For example, mass and temperature have a magnitude but no direction. Temperature has negatives and positive. It's a signed scalar quantity, but it has no direction. As opposed to scalar quantities, vector quantities have size or magnitude and direction. For example, force, displacement, velocity, and acceleration. The first notation we'll learn for a vector is AB with an arrow over top of it. A is the tail and B is the head. The vector AB is the position vector of B relative to A, or from A. We start at A and we go to B, and we call that vector AB. An important concept is the concept of the position vector. A position vector of V says we're taking a vector OC where O is on the origin 0, 0. So a position vector OC starts at 0, 0 with its tail and its head is at C at some point x, y. Our second notation for a vector is a singular letter attached to an arrow. A small letter, A, would designate this as vector A. The magnitude of the vector is the vector's length, placed tail to head. The notation is AB, or A, put in the absolute value signs, noting that the magnitude of a vector is always positive. Equal vectors have the same magnitude and the same direction. If vector A equals vector B, that means that they point in the same direction and the magnitude of A is equal to the magnitude of B. Free vectors are vectors with no specific position associated with them. They have no reference to a fixed point in space. Negative vectors. The negative vector A, or negative A, is the vector A but pointing in the opposite direction. If vector A points to the right, vector negative A is the same magnitude but it points in the opposite direction. Note the magnitude of A is the same as the negative A vector. Or if you're using the other notation, we can say vector AB has the same magnitude as vector BA. Another word for vector BA would be the opposite of AB. Note that the magnitude of AB is the same as the magnitude of negative AB, which is the same as the magnitude of BA, because these two are the same. We also have to be aware of the zero vector. A zero vector has a magnitude of 0. You see its magnitude is equal to 0 and no direction. For any non-zero vector A, the magnitude of A will be greater than 0. A zero vector is represented geometrically by joining a point unto itself. It really is just a point. Here's a good question. What are vectors good for? Vectors are very useful when representing positions relative to some starting point. And often our starting point is 0, 0, but it doesn't have to be.